Alright guys, welcome back. This time in Netcode for Entities, we're going to take a quick look at physics and how it works over the network. If you remember from last time, we had interpolated ghosts and predicted ghosts. The interpolated ghosts are going to be controlled by the server. The predicted ghosts are the ones that you control yourself locally. With physics, what this means is that the interpolated ghosts controlled by the server on the client side, they will be kinematic. So by default, you're not going to be able to move them locally. They only move by command sent from the server. On the client side, for the predicted ghosts, they'll be non-kinematic. But for the player, the way we're going to be doing it here, the player is going to be kinematic because we're moving it directly. So the way the physics simulation actually works is there is a separate world for all your entities that will contain all of your physics entities and all the physics calculation systems. The physics system will need to know the actual tick that these commands are coming from, because the way the client prediction works is that it will resimulate all of the physics once it gets older ticks in, and you can go ahead and resimulate those in order to get accurate predictions. With regards to the multiple physics worlds, it's possible to have more than the one physics world. You can have worlds that just do your particle effects, or if you wanted to do like grenade throw trajectories, you could have a world that is specifically just to calculate those like graphics things client side. All right, and we're not going to go too far into the prediction system. That's going to be a topic for itself. So let's take a look at what we've got going on here in Unity. So we've got a physics scene. And it's basically the same scene as before, but our player is now a prefab variant of our previous player. This just has our rigid body on it. I don't remember if we put that on there last time or not, but this will automatically get converted into a physics body on the entity side. We do have it use gravity. We have it set to kinematic. The collision detection is discrete. I don't think it actually matters if we change that or not. We also have a velocity authoring script, which is just float there. And the ghost is going to be remaining the same here. There is some config components that you'll need to set up here as well. I think the only thing actually required is the physics step component here, and this is where you can change the actual physics engine. So by default, we got Unity Physics. There is also the Havoc Physics if you have a Unity Pro license. The physics step component here, you can control your gravity, the solver iterations, which will just how many iterations it will take on the CPU to calculate all of your rigid body stuff, whether it's multi-threaded or not. And then there is the synchronized collision world, which we're not worrying about here, and also the enable contact server stabilization. So what this does is for rigid bodies that are stacked on top of each other affected by gravity, you'll have gravity pulling it down, and then the collider is pushing it back up. Without this enable contact server solver, you'll start getting like bouncing and jiggling around, which you might not want for like a stack of boxes. There is a netcode physics config. If you want to enable lag compensation, this will tell the system how many ticks it wants to save. Unity Physics is stateless, so that means you don't actually have to have the previous states in order to calculate your future states. This is what makes like rollback netcode possible. So you can just grab a random tick from 30 seconds ago or whatever, and then resimulate back up to current if something went wrong with your prediction. Havoc Physics is stateful, so you can't quite do the same rollback that you can with Unity Physics. And then this is the physics world index. This is in case you have multiple worlds doing other things. You want to know which world that you're currently working in. And then this is a debug component here. Okay, so this random object authoring script I got from the component samples in the physics samples here in over here. I don't quite remember where. I think it's in common. Spawn random authoring. And here's the system. I'll also put a copy of the repo I'm actually working on here in the description as well. So this is just a random spawner. It's going to end up spawning, right now it's set to 100, just random spheres. Our spheres are the same as we used last time. Just have the collider and the rigid body there with the velocity. All right, and we'll go in through some of the code here in just a second. I've got a system that will attract all of the spheres to your player, And then when you click left click, it will cause an explosion and throw the spheres away from the player. Well, go back to our main menu. Did some changes to the connection manager. We just have a address and a port number and a scene that we can just type in the name of the scene to quickly swap between the different scenes. So here we go. You can move around. As you move, the spheres will follow you around. You can left click, throw them away. There we go. And if we pop in a thin client, I don't have movement set up on the thin client yet, but we'll get to that. Okay. So let's get into some of the code here real quick. Here is the bootstrapper. Nothing has changed there. We've got it set to connect manually. The connection manager here, we've just got the address, port, and scene. I'm starting host manually just in the editor, just for convenience. Here in start host, I don't think anything's changed since the last time we looked at this. We're creating our server client world, destroying the default world, making our server default, changing the scene, connecting. When we start client, I've got this on my laptop currently. So when you want to start the client, it will connect to the scene that we have through the address that we set and the port here. In the host, it just connects to the default connect address, which was like 0.0.0.0. Player input, this did change. So we moved from the input command data just to the regular command data here. And we have this set up to also send these commands to non-owners, because for the physics, we are sending commands to all other clients. And we also will need to send the network tick as well, so the physics system can do its prediction properly. Now, because it's a command data here, we have to add it to the buffer instead of doing the add component I believe we did last time. Here in the input system, we're using the same default input actions. We still have our player input and our network ID. Here is a little bit different. We are still getting our, for each dynamic buffer with our player input, we want to make sure that this is our local ghost and with entity access. We're just creating a new player input. We are grabbing our tick from the network time. So this is going to be the current time that the client believes it is. We are grabbing our movement and our fire here. We're doing this as a float because the was pressed at this frame does not seem to work, and I'm not sure why, but this works just as well. So when we hit the button, buttons are floats in the input system, which is kind of weird, but whatever. And then if it is greater or if it's not 0, we're just going to set it our fire.set. And then here we get the dynamic buffer from our entity, and then we will add our command data to it. Each player will have their own input buffer, and then we just add to that. Our player move system has changed quite a bit. First, our groups here. We have a physics system group. Now, when the netcode is initialized, it will move these physics groups, and I believe the fixed update will move it into its own predicted physics group. And this is so it can get rerun multiple times per frame if need be. So yeah, our move system here is system base. We are just requiring a player input. Here we are getting the current tick once again. We are using entity command system here. We're just using the begin fixed step simulation entity command buffer system. There's probably a more efficient way of using this, but this works. We've also set this up as a job. You could still do this with the for each loop, but I wanted to get practice with actually making jobs. So this is 2 separate jobs. There's the move job and then the player explode job. The move job can be scheduled in parallel. You're not going to see that much benefit here from that because there's only a few players. And even at most, you're like talking maybe 100 players. So you don't really get the benefits of parallel processing until you get into the thousands and hundreds of thousands of entities. And then we also have our explode job here. This one could not be scheduled parallel because of the physics world. So in our job here, we are grabbing the tick from the update here. And then for the input buffer here, there is a get data at tick. So this will run whenever the server gets a tick from any of the clients. And those ticks don't necessarily come in order, which is why the physics system runs multiple times to get caught up. So you just need to know what tick these commands are actually getting sent at. And so we basically dump our vector2 movement from the input system into a float3. We will grab the magnitude of that vector just to make sure that it is actually moving. We'll normalize it so our up left corners don't move twice as fast as just regular up. And then we'll just grab our speed here for our direction. And then here we are just assigning the physics velocity just directly into our direction. There is a what is it? Apply. There is apply angular impulse, apply linear impulse, apply explosion force. We'll look at that a little bit. And these just require more components to actually set. So if you wanted to grab your mass, you could do that as well. But since we are just moving our player around, linear is fine. We also have the simulate tag here, which I believe the simulate gets removed when the prediction rollbacks are happening, so you don't get double and triple inputs whenever that resimulate happens. So the explode job is pretty much the same. We grab our data at our particular tick. Then we will check if our fire is set. Here we grab a new list. And for the physics sphere cast, or I guess overlap sphere, you call the physics world overlap sphere, and then you just give it a position, radius, the list that you want to dump it out into, and the collision filter. And then we'll loop through everything that got hit. We're going to add an exploded component to it, and then we set our data here. And the explosion component is just the position, force, radius. That's all we need. And then I also had a thing here that would move the player up whenever you did that, but it didn't look right, so I cut it out. So for the attractor system here, we're just doing this just on the server. And this one is a short one, but we are just grabbing all of the local transforms with a move speed and a physics velocity and mass. And yeah, because we are just applying linear force to that. And then we loop through all of our players. You can do these nested for each queries. Like I said, there's probably a better way to do this, but this was super quick and easy, and I think it's pretty easy to understand as well. So we just grab the direction from the player to our sphere. We'll get the distance of it, and then if the distance is more than 1, we'll just apply a force towards the player and then multiply it by delta time. And finally here, the explosion. Also on the server, and much the same way, all we're doing is we are getting a entity command buffer here. This one, apply explosion force, requires quite a few components. There's probably a better way of doing this, but I wanted some practice. So yeah, this is just getting the mass, a collider, transform position, transform rotation, a force, the position of the explosion, the radius of the explosion, the up direction, and then the force mode. Force modes, I believe, is the same as regular game object force modes. You've got the force, impulse, acceleration. Where's the impulse? And yeah, I believe that is all we need. We can hold the mouse down to get continuous explosions. You can see the entity count over on the server world here. We've got explosion entities being created, and then they'll get removed by the explosion system. We can, real quick, check out the spawner, and we can bump this up to something crazy. We can do 1,000. We can do 2,000. Here, and then we're not going to see a whole lot here. Our frame rate is still sitting at 30-ish. You see we've got 2,000 entities. If I can get the physics themselves gets a bit chunky, but the player can still move if I didn't just fly off the edge, which I may have. Oh yeah, I'm way over there now. I don't think I can come back. But yeah, so next time we will probably go into more of the raycasting and hit detection. So we're going to actually start shooting some stuff next time. That will also get us into more of the prediction and syncing up and how all that will work. So yeah, if you guys got any other questions, definitely leave a comment down below and we'll try to help you out. Right, see you next time.